Close your eyes and let the weight of the day melt away. Imagine yourself floating in the vast, endless expanse of space, where the universe stretches out in every direction, silent and serene. Tonight, we invite you to drift into a journey unlike any other, a journey to the very beginning of everything. This is the story of the cosmic dawn, the moment when the first stars ignited, piercing the darkness and lighting up the cosmos for the very first time. Picture a time before galaxies, before planets, before light itself, a time when the universe was a quiet, shadowy void, waiting for its first breath of brilliance. As you settle in, let your mind wander to this ancient era, where the first sparks of starlight began to weave the fabric of the universe as we know it. Where are you joining us from, and what time is it there? Wherever you are, whatever the hour, let this be your moment to relax, to dream, and to explore the mysteries of the cosmic dawn. Together, we'll uncover the secrets of the first stars, those ancient beacons that forever changed the universe. So take a deep breath, let go of the day, and allow yourself to be carried away by the story of how it all began. Now let us travel back in time to the very moment when everything began. Picture a universe that is not yet a universe, a place where there is no light, no stars, no galaxies. Only an infinite, silent darkness. This is the story of the Big Bang, the event that set the stage for all that would come. Imagine a single point, unimaginably small and dense, containing all the energy and matter that would one day become the cosmos. In an instant, this point expanded, not into space, but as space itself. The universe burst into existence, a fiery explosion of energy and potential. Yet, in those first moments, there was no light to see. The universe was a swirling sea of particles, too hot and chaotic for anything to form. As it expanded and cooled, the first atoms began to emerge, simple hydrogen and helium, the building blocks of everything. But still, the universe remained dark, a vast and empty canvas, waiting for its first brushstroke of light. This was the beginning of the cosmic dawn, a time when the universe was young, quiet, and full of promise. As you drift deeper into this ancient era, imagine the stillness, the calm before the storm of creation. The universe was waiting, holding its breath, for the first stars to ignite and bring light to the darkness. As the universe continued to expand and cool, it entered a phase of profound stillness, a time known as the cosmic dark ages. Picture this vast, empty expanse, filled only with the simplest of elements, hydrogen and helium, floating in the darkness like invisible clouds. There were no stars, no galaxies, no sources of light to pierce the endless void. It was a time of quiet anticipation, as if the universe itself was holding its breath, waiting for something extraordinary to happen. The temperature dropped, and the particles of gas began to drift, slowly gathering in the faintest whispers of gravity. Yet, even as these clouds of gas grew denser, the universe remained shrouded in darkness. No light shone to illuminate the scene, no heat radiated to warm the cold emptiness. It was a time of stillness, a pause in the cosmic story, where the universe seemed to rest, gathering its energy for the next great act. Imagine the silence of this era, a silence so deep and vast that it stretched across billions of years. This was the cosmic dark ages, a time of waiting, of potential, and of quiet preparation for the dawn that was yet to come. As you drift through this ancient darkness, let the stillness envelop you, a reminder of the calm before the universe's first light would finally break through. And then, after eons of silence and darkness, something extraordinary began to stir. Deep within those vast clouds of hydrogen and helium, the faintest whispers of gravity grew stronger, pulling the gas closer and closer together. Slowly, almost imperceptibly, the first glimmers of light began to emerge. This was the cosmic dawn, the moment when the universe's first stars ignited, piercing the endless night with their radiant glow. Picture it, tiny sparks of light flickering to life in the vast cosmic void, like the first candles lit in a darkened room. These were not the stars we know today, but massive, luminous giants, born from the simplest of ingredients. Their light was raw and pure, a brilliant contrast to the darkness that had reigned for so long. As these stars began to shine, they illuminated the surrounding gas, creating pockets of warmth and energy in the cold, empty universe. It was a slow and gradual process, but with each new star that formed, the darkness began to retreat, giving way to a universe that was no longer silent and still. Imagine the awe of witnessing this transformation, the first light breaking through the cosmic shadows, signaling the beginning of a new era. This was the dawn of starlight, the moment when the universe took its first steps toward the vibrant, luminous cosmos we know today. As you drift through this ancient scene, let the warmth of these first stars fill your imagination, a reminder of the beauty and wonder that emerged from the depths of the cosmic dark ages. Now, as we move deeper into this cosmic tale, let's explore how these first stars came to be. Imagine the universe as a vast, quiet ocean, where clouds of hydrogen and helium drifted aimlessly, like mist over still waters. But beneath this calm surface, something powerful was at work: gravity. Like an invisible hand, gravity began to gather these clouds, pulling them closer and closer together. At first, the process was slow, almost imperceptible, as if the universe itself was holding its breath. But as the gas grew denser, the pull of gravity grew stronger, compressing the clouds into tighter and tighter knots. Within these knots, the temperature began to rise and the pressure built, like a storm gathering strength. And then, at the heart of these swirling clouds, something extraordinary happened. The gas became so hot and dense that it ignited, sparking the birth of the first stars. These were not the stars we see today, scattered across the night sky. They were colossal, blazing giants, born from the simplest elements, hydrogen and helium. Their light was fierce and pure, a brilliant beacon in the darkness. Picture this process as a cosmic dance, where gravity led the way, guiding the gas into swirling motions until the moment of ignition brought forth the first stars. It was a slow, rhythmic process, like the universe itself was finding its voice, one star at a time, and as these stars began to shine, they lit up the surrounding gas, creating pockets of warmth and energy in the cold, empty expanse. This was the universe's first act of creation, a delicate balance of forces that would shape everything to come. As you imagine this scene, let the gentle pull of gravity and the birth of these first stars fill your thoughts, a reminder of the quiet, powerful forces that brought light to the cosmos. And now, as we continue this journey, let's turn our attention to the ingredients that made these stars so unique and how their simplicity set the stage for the universe we know today. Now, let's take a closer look at what made these first stars so extraordinary. Unlike the stars we see today, which are filled with a rich tapestry of elements, the first stars were remarkably simple. They were made of just two ingredients, hydrogen and helium. These were the only elements present in the early universe, forged in the fiery aftermath of the Big Bang. Picture them as the universe's first recipe, a blend so basic yet so powerful that it set the stage for everything to come. Hydrogen, the lightest and most abundant element, made up the bulk of these stars. It was the fuel that allowed them to burn so brightly, transforming into helium through the process of nuclear fusion. Helium, the second lightest element, was created in the hearts of these stars as they burned, a byproduct of their immense energy. Together, these two elements formed the building blocks of the first stars, pure and untainted by the heavier elements that would come later. This simplicity is what made the first stars so unique. Modern stars, like our own sun, contain traces of heavier elements such as carbon, oxygen, and iron elements that were absent in the early universe. These heavier elements were created much later, in the fiery explosions of the first stars' deaths. But in the beginning, the universe was a blank canvas, and the first stars were its first brush strokes, painted with only the lightest and simplest of colors. Imagine these stars as cosmic pioneers, blazing a trail through the darkness with nothing but hydrogen and helium to guide them. Their light was pure and uncomplicated, a stark contrast to the complex chemistry of stars today. And yet, it was this very simplicity that allowed them to shine so brightly, illuminating the universe in ways that would shape its future. As we reflect on the ingredients of the first stars, we're reminded of the beauty of beginnings. These stars were the universe's first attempt at creation, a testament to the power of simplicity. And as we continue our journey, we'll see how their light and legacy would go on to transform the cosmos, paving the way for the stars, galaxies, and even life itself. Now, let's turn our gaze to the sheer scale and brilliance of these first stars. Unlike the stars we see today, which vary widely in size and brightness, the first stars were true giants of the cosmos. Imagine stars so massive that they dwarfed even the largest stars in our modern universe. These cosmic titans were hundreds of times more massive than our sun, and their luminosity was unmatched, blazing with an intensity that pierced the darkness of the early universe. Their immense size meant they burned through their fuel at an astonishing rate. While a star like our sun can shine steadily for billions of years, the first stars lived fast and died young, their lives measured in mere millions of years. Yet, in that short time, they radiated an extraordinary amount of energy, lighting up the cosmos in ways that had never been seen before. Picture these stars as cosmic beacons, their light traveling across vast distances, illuminating the void. Their brilliance was not just a product of their size, but also their purity. Made solely of hydrogen and helium, they burned hotter and brighter than any stars that would come after them. This made them not only luminous, but also mysterious, their light carrying secrets about the universe's earliest days. Despite their incredible power, these stars were also incredibly distant, both in space and time. They existed in an era so far removed from our own that their light has long since faded, leaving only faint echoes for us to study. Yet, their impact was profound. The energy they released helped shape the universe, ionizing the surrounding gas and setting the stage for the formation of galaxies. As we consider the size and power of the first stars, we're reminded of their dual nature, both awe-inspiring and enigmatic. They were the universe's first great light sources, yet their story remains shrouded in mystery, waiting to be uncovered by the tools of modern astronomy. And as we continue our journey, we'll explore how their legacy continues to influence the cosmos, even billions of years later. Now, let's shift our focus to a hidden force that played a pivotal role in the birth of the first stars: dark matter. While the first stars themselves were luminous and awe-inspiring, their formation relied on something invisible yet immensely powerful. Dark matter, though it neither emits nor reflects light, was the silent architect behind the scenes, shaping the early universe in ways that allowed these cosmic giants to emerge. Picture the early universe as a vast, dark canvas, with clouds of hydrogen and helium gas scattered across its expanse. These clouds were the raw materials for the first stars, but they needed something to bring them together. That's where dark matter came in. Acting like a cosmic glue, dark matter's gravitational pull began to gather these gas clouds into dense clumps. Over time, these clumps grew denser and hotter, creating the perfect conditions for the first stars to ignite. What makes dark matter so fascinating is its mysterious nature. We can't see it directly, but its presence is felt through its gravitational influence. Without dark matter, the gas in the early universe might have remained too spread out, never reaching the densities required to form stars. It was the invisible scaffolding that held everything together, allowing the first stars to shine. This interplay between dark matter and ordinary matter is a reminder of how interconnected the universe truly is. While the first stars were the visible result of this cosmic dance, dark matter was the unseen partner, guiding the process every step of the way. Its role adds a layer of intrigue to the story, as we're left to wonder about the true nature of this enigmatic substance and how it continues to shape the cosmos today. As we reflect on the role of dark matter, we're reminded that the universe is full of mysteries waiting to be uncovered. And as we move forward, we'll explore how these first stars, born from the interplay of light and shadow, went on to shape the galaxies we see today. As we journey further into the story of the cosmic dawn, let's turn our gaze to what came next: the birth of the first galaxies. These early galaxies were not just random collections of stars. They were the universe's first attempts at creating order out of chaos, a cosmic community born from the light of the first stars. Imagine the first stars, scattered across the vast darkness of space, beginning to cluster together. Gravity, the same force that brought gas clouds together to form stars, now worked on a grander scale. It pulled these stars closer, grouping them into the earliest galaxies. These galaxies were small compared to the ones we see today, but they were the seeds of the cosmic structures that would eventually fill the universe. Within these early galaxies, The first stars shone brightly, their light illuminating the surrounding gas and dust. Over time, more stars formed, adding to the growing communities. These galaxies became the building blocks of the universe, the first neighborhoods in a cosmos that was slowly becoming more organized and interconnected. What's remarkable is how these early galaxies laid the foundation for everything that followed. They were the first steps in the universe's journey toward complexity, creating the environments where future stars, planets, and even life could emerge. The first galaxies were not just collections of stars, they were the birthplaces of cosmic history, the places where the story of the universe truly began to unfold. As we reflect on these early galaxies, we're reminded of the power of connection. Just as the first stars came together to form galaxies, the universe itself is a tapestry of relationships, where every piece plays a role in the larger story. And as we continue our journey, we'll explore how the light of these first galaxies began to transform the universe, bringing an end to the cosmic dark ages and ushering in a new era of light and possibility. Now, let's step into the glow of the first stars and witness how their light began to reshape the cosmos. Picture this: the universe, once cloaked in darkness, now flickering with the faint but growing light of these ancient stars. Their brilliance wasn't just a beacon in the void, it was a force of transformation. As these stars burned, their intense ultraviolet light began to interact with the surrounding gas, a process known as ionization. Imagine the gas clouds, made mostly of hydrogen, as vast, silent oceans. The light from the first stars acted like a cosmic tide, slowly breaking apart the hydrogen atoms into their basic components, protons and electrons. This process, called reionization, was like turning on a cosmic switch, one that would eventually illuminate the entire universe. Over millions of years, the light from these stars spread outward, carving out bubbles of ionized gas that grew larger and larger, like ripples in a pond. This wasn't just a physical change, it was a turning point in the story of the universe. The once neutral gas, which had absorbed light and kept the cosmos dark, was now becoming transparent. Light could travel farther, and the universe began to open up, revealing its secrets. The era of the cosmic dawn was giving way to a new age, one where light could pierce through the darkness and illuminate the path for future generations of stars and galaxies. What's fascinating is how this process unfolded over such vast stretches of time. It wasn't sudden or dramatic, but gradual and persistent, like the slow rise of dawn on a distant horizon. The light of the first stars didn't just brighten the universe, it fundamentally changed its nature, setting the stage for everything that would come after. As we reflect on this moment, we're reminded of the profound impact of even the smallest beginnings. The light of the first stars, though faint at first, sparked a chain reaction that would eventually light up the cosmos. And as we continue our journey, we'll explore how this light brought an end to the cosmic dark ages, ushering in a new era of possibility and wonder. As we move forward in this cosmic tale, let's pause to consider the profound shift that occurred as the light of the first stars began to spread. This was no ordinary light. It was the herald of a new era, one that would bring an end to the cosmic dark ages. For billions of years, The universe had been a place of shadow, where light struggled to pierce through the dense fog of neutral gas. But now, the first stars were changing everything. Their light, though faint at first, began to carve out pockets of clarity in the cosmic haze. Imagine the universe as a vast, dark room, and the first stars as tiny candles being lit one by one. At first, their glow was barely noticeable, but as more stars ignited, their combined light grew stronger, pushing back the darkness. This wasn't just a visual change, it was a transformation of the very fabric of the universe. The process of reionization, driven by the light of these stars, was like a cosmic awakening. The once neutral hydrogen gas, which had absorbed light and kept the universe opaque, was now being ionized, becoming transparent. Light could travel farther, and the universe began to open up, revealing its hidden structures. This marked the end of the cosmic dark ages, a time when the universe was cloaked in silence and shadow. What's remarkable is how this change unfolded. It wasn't a sudden flash of light, but a gradual, persistent glow that spread across the cosmos. Over millions of years, the light from the first stars created bubbles of ionized gas, which grew and merged like ripples on the surface of a pond. These bubbles eventually connected, forming a network of light that illuminated the universe. This era of renewal brought with it a sense of hope and possibility. The universe, once a place of darkness and mystery, was now becoming a stage for the formation of galaxies, stars, and planets. The light of the first stars didn't just brighten the cosmos, it set the foundation for everything that would come after. It was a reminder that even in the vastness of space, small beginnings can lead to monumental change. As we reflect on this pivotal moment, we're reminded of the resilience and creativity of the universe. The end of the cosmic dark ages wasn't just a physical transformation. It was a story of hope, renewal, and the enduring power of light. And as we continue our journey, we'll see how this light paved the way for the next chapter in the universe's story, one filled with even greater wonders. As we step into the next chapter of this cosmic journey, let's turn our gaze to the dramatic final act of the first stars. These ancient giants, born from the simplest ingredients of hydrogen and helium, lived lives that were as brief as they were brilliant. But their end was even more spectacular, a cosmic crescendo that would forever change the universe. When the first stars reached the end of their lives, they didn't fade quietly into the darkness. Instead, they exploded in colossal supernova, events so powerful they could outshine entire galaxies. These explosions were not just moments of destruction, they were also acts of creation. As the stars tore themselves apart, they scattered their innermost materials across the cosmos, seeding the universe with the first heavy elements. Elements like carbon, oxygen, and iron, which are essential for life as we know it, were forged in the hearts of these stars and then flung into space by their explosive deaths. This was the universe's first act of recycling, turning the remnants of one generation of stars into the building blocks for the next. The supernova of the first stars were like cosmic forges, transforming the simple into the complex and laying the groundwork for everything that would follow. But the impact of these supernovae went beyond just creating new elements. The shockwaves from these explosions rippled through the surrounding gas, compressing it and triggering the formation of new stars and galaxies. In this way, the death of one star became the birth of many others. It's a reminder that even in destruction, there is creation, a cycle that has shaped the universe from its earliest days to the present. What's truly awe-inspiring is the scale of these events. The energy released by a single supernova was enough to outshine billions of stars, and the heavy elements it produced would go on to form planets, moons, and even life itself. The first supernova were not just the end of an era, they were the beginning of a new one filled with complexity, diversity, and possibility. As we reflect on these cosmic explosions, we're reminded of the dual nature of the universe, a place where destruction and creation are intertwined, where endings are also beginnings. The first supernova were a testament to the power of transformation, showing us that even in the vastness of space, change is the only constant. And as we continue our journey, we'll see how these explosive events set the stage for the next great chapter in the story of the cosmos. Now, let's turn our attention to what came after the fiery end of the first stars. The remnants of those ancient giants didn't simply vanish into the void. Instead, they became the seeds of something new, something that would carry the story of the universe forward. When the first stars exploded, they left behind clouds of gas and dust, enriched with heavy elements. These clouds, scattered across the cosmos, became the raw materials for the next generation of stars. Gravity, the great sculptor of the universe, began to pull these clouds together, compressing them until new stars ignited. But this time, the stars that formed were different. They were no longer made of just hydrogen and helium. Now they contained traces of carbon, oxygen, and other elements forged in the hearts of their predecessors. These new stars were smaller, cooler, and longer lived than the first generation, and around them, something extraordinary began to happen. The heavy elements in their surrounding clouds clumped together, forming the first solid particles. Over time, these particles grew into rocks, then asteroids, and eventually planets. For the first time, the universe had the ingredients for worlds that could one day support life. This process of creation and recreation is one of the most beautiful aspects of the cosmic story. The first stars, though long gone, left behind a legacy that continues to shape the universe. Every star you see in the night sky, every planet, and even the elements that make up your body, can trace their origins back to those ancient supernova. It's a reminder that the universe is deeply interconnected. The death of one star becomes the birth of another, and the elements created in the heart of a dying star become the building blocks of new worlds. This cycle of creation and destruction has been repeating for billions of years, and it's still happening today. As we look out into the cosmos, we're not just seeing distant stars and galaxies. We're seeing the echoes of the first stars, the remnants of their explosive deaths, and the seeds they planted for the future. It's a story of continuity, of how the universe builds upon itself, layer by layer, generation by generation. And as we continue our journey, we'll see how these seeds of future stars set the stage for the next great act in the cosmic drama, the formation of galaxies and the intricate dance of stars and planets that would follow. Now, let's take a step forward and explore how the faint echoes of the first stars' light continue to captivate astronomers today. These ancient glimmers, though incredibly faint, hold the key to understanding the earliest chapters of our universe. To uncover these secrets, scientists rely on some of the most advanced telescopes ever built, instruments designed to peer back in time and capture the whispers of light that have traveled across billions of years. The light from the first stars is not something we can see directly. It's been stretched and dimmed by the expansion of the universe, shifting into wavelengths that are invisible to the human eye. But modern telescopes, equipped with sensitive detectors, can pick up these faint signals. By studying this ancient light, astronomers can piece together the story of how the first stars formed, how they lived, and how they shaped the cosmos around them. One of the most remarkable tools in this quest is the James Webb Space Telescope. Launched to observe the universe in infrared light, it's uniquely suited to detect the stretched remnants of the first star's glow. By focusing on distant galaxies and the faint afterglow of the cosmic dawn, this telescope allows scientists to glimpse a time when the universe was young and filled with the first sparks of starlight. But the search for the first stars doesn't end with telescopes. Astronomers also study the cosmic microwave background, the faint afterglow of the Big Bang itself. Embedded within this ancient light are subtle clues about the era of the first stars. Tiny variations in temperature and density reveal how the first stars ionize the surrounding gas, leaving behind a faint imprint that scientists can decode. This process of decoding the universe's earliest light is like piecing together a cosmic puzzle. Each observation, each faint signal, adds another piece to the story. And as we gather more data, the picture becomes clearer, revealing how the first stars ignited and how their light began to transform the universe. It's a humbling thought that the light we detect today began its journey when the universe was in its infancy. These echoes of the first stars are not just remnants of the past. They are a bridge to understanding how everything we see around us came to be. And as we continue to explore, we'll uncover even more about these ancient beacons and the role they played in shaping the cosmos. With each discovery, we're reminded that the universe is not just a collection of stars and galaxies. It's a living story, one that began with the first stars and continues to unfold with every new observation. And as we turn our gaze to the next chapter, we'll see how these early stars set the stage for the formation of galaxies, the intricate structures that would come to define the universe we know today. Now, let's turn our attention to one of the most fascinating remnants of the universe's earliest moments, the cosmic microwave background. This faint afterglow, often referred to as the echo of the Big Bang, is a treasure trove of information about the universe's infancy. It's like a snapshot of the cosmos when it was just a few 100,000 years old, a time when the universe was a hot, dense soup of particles and energy. As the universe expanded and cooled, this primordial light was stretched into microwave wavelengths, creating a faint glow that permeates the entire cosmos. Today, this glow is incredibly faint, but it's detectable with the right instruments. What makes the cosmic microwave background so special is that it carries imprints of the universe's earliest structures, tiny fluctuations in temperature and density that would eventually grow into the stars, galaxies, and cosmic web we see today. These fluctuations are like fingerprints left behind by the first stars. When the first stars ignited, their intense light began to ionize the surrounding hydrogen gas, a process known as reionization. This left subtle marks in the cosmic microwave background, clues that scientists can use to piece together the story of how the first stars formed and how they influenced the universe around them. Studying the cosmic microwave background is like reading a cosmic diary. By analyzing its patterns, astronomers can uncover details about the universe's composition, its rate of expansion, and even the nature of dark matter and dark energy. It's a window into a time when the universe was still in its infancy, a time when the first stars were just beginning to light up the cosmic darkness. What's truly remarkable is that this ancient light has been traveling through space for over 13 billion years, carrying with it the story of the universe's birth and early evolution. Every time we observe the cosmic microwave background, we're not just looking at light, we're peering into the past, uncovering the secrets of how the universe transformed from a hot, dense state into the vast, structured cosmos we know today. As we continue to study this cosmic relic, we're reminded of the profound connection between the first stars and the universe we inhabit. The cosmic microwave background is more than just a scientific curiosity. It's a testament to the enduring legacy of the first stars and their role in shaping the cosmos. And as we move forward, we'll see how these early stars set the stage for the formation of galaxies, the intricate structures that would come to define the universe we know today. Now, let's shift our focus to the ongoing quest to uncover the first stars themselves. Despite the incredible progress we've made in understanding the cosmic dawn, directly observing these ancient stars remains one of the greatest challenges in modern astronomy. The first stars, often referred to as population 3 stars, are incredibly elusive. They existed so long ago, in a universe so vastly different from our own, that their light has traveled for over 13 billion years to reach us. By the time it does, it's incredibly faint and stretched into the infrared part of the spectrum, making it nearly invisible to traditional telescopes. One of the biggest hurdles is the sheer distance. The first stars formed during a time when the universe was still in its infancy, and their light has been traveling through space ever since. Over such vast distances, the light becomes diluted and distorted, blending into the cosmic background. To make matters even more challenging, the first stars were relatively short-lived, burning brightly for only a few million years before exploding as supernova. This means that by the time their light reaches us, the stars themselves are long gone, leaving behind only faint traces of their existence. Another obstacle is the cosmic fog that filled the early universe. Before the first stars ignited, the universe was shrouded in a thick haze of neutral hydrogen gas. This gas absorbed much of the light from the first stars, making it even harder for us to detect them today. It wasn't until these stars began to ionize the surrounding gas, during the era of reionization, that the universe started to become transparent. But even then, the light from the first stars had to travel through this newly ionized gas, which further scattered and dimmed it. To overcome these challenges, astronomers rely on some of the most advanced technology ever built. Telescopes like the James Webb Space Telescope are designed to peer into the infrared spectrum, where the light from the first stars is most likely to be found. By studying the faintest, most distant objects in the universe, scientists hope to catch a glimpse of these ancient stars or their remnants. They also look for indirect evidence, such as the chemical fingerprints left behind by the first stars in the form of heavy elements scattered across the cosmos. The search for the first stars is not just about finding ancient light, it's about uncovering the origins of everything we see today. These stars were the pioneers of the universe, the first to ignite and illuminate the cosmic darkness. By studying them, we gain insight into how the universe evolved from a simple, dark expanse into the complex, structured cosmos we know today. And while the first stars may remain elusive for now, the pursuit of their discovery continues to push the boundaries of our knowledge and technology, reminding us of the endless mysteries waiting to be uncovered in the vastness of space. As we venture further into the mysteries of the cosmic dawn, one tool stands out as a beacon of hope in our quest to uncover the secrets of the first stars: the James Webb Space Telescope. This remarkable piece of technology, often referred to as the successor to the Hubble Space Telescope, is designed to peer deeper into the universe than ever before. Its advanced instruments are finely tuned to detect the faint infrared light emitted by the first stars, light that has been stretched and dimmed over billions of years as it traveled across the cosmos. With its massive gold-coated mirror and state-of-the-art sensors, the James Webb Space Telescope is uniquely equipped to cut through the cosmic fog and reveal the earliest chapters of the universe's story. What makes this telescope so extraordinary is its ability to observe in the infrared spectrum, where the light from the first stars is most likely to be found. Unlike visible light, which is easily absorbed or scattered by dust and gas, infrared light can pass through these obstacles, allowing us to see farther and clearer than ever before. This capability is crucial for studying the era of the cosmic dawn, when the universe was still cloaked in a veil of neutral hydrogen gas. By capturing the faint glow of the first stars, the James Webb Space Telescope offers us a window into a time when the universe was just beginning to light up. But the telescope's mission goes beyond simply detecting ancient starlight. It also aims to uncover the chemical signatures left behind by the first stars. When these stars exploded as supernova, they scattered heavy elements like carbon, oxygen, and iron across the cosmos. These elements became the building blocks for future generations of stars, planets, and even life itself. By analyzing the light from distant galaxies, the James Webb Space Telescope can identify these chemical fingerprints, helping scientists piece together the story of how the first stars shaped the universe. The anticipation surrounding this telescope is palpable. Every image it captures, every spectrum it analyzes, brings us closer to understanding the origins of the cosmos. It's not just about finding the first stars, it's about unraveling the intricate web of events that transformed a dark, empty universe into the vibrant, structured cosmos we see today. The James Webb Space Telescope is more than a scientific instrument. It's a time machine, allowing us to witness the birth of light and the dawn of complexity in the universe. As we await the next groundbreaking discovery from this incredible telescope, we're reminded of the boundless curiosity that drives us to explore the unknown. The James Webb Space Telescope is not just a tool for scientists, it's a symbol of humanity's enduring quest to understand our place in the universe. And as it continues to unveil the secrets of the cosmic dawn, it invites us all to share in the wonder of discovery, one faint glimmer of ancient light at a time. As we turn our gaze to the theories surrounding the first stars, we find ourselves stepping into a realm of scientific wonder and speculation. These ancient celestial bodies, born in the infancy of the universe, have left behind tantalizing clues that scientists are still piecing together. One of the most widely accepted theories suggests that the first stars formed from vast clouds of hydrogen and helium, the only elements present in the early universe. Under the relentless pull of gravity, these clouds began to collapse, heating up until nuclear fusion ignited, giving birth to the first stars. These stars, often referred to as population 3 stars, were unlike anything we see today. They were massive, hundreds of times larger than our sun, and burned with an intensity that lit up the cosmic darkness. Another intriguing theory proposes that dark matter played a crucial role in the formation of these early stars. Dark matter, invisible and mysterious, is thought to have created the gravitational scaffolding that allowed gas to accumulate and condense into stars. Without this unseen force, the universe might have remained a diffuse sea of gas, never coalescing into the brilliant beacons that marked the end of the cosmic dark ages. This interplay between dark matter and ordinary matter is a key focus of modern astrophysics, offering insights into how the first stars came to be. Some scientists also speculate that the first stars may have formed in clusters rather than in isolation. These clusters, or mini-galaxies, would have been the precursors to the larger galaxies we observe today. Within these dense environments, stars could have interacted, collided, and even triggered waves of star formation, creating a dynamic and rapidly evolving cosmic landscape. This theory helps explain how the universe transitioned from a dark, featureless expanse to a vibrant tapestry of light and structure. Yet another fascinating idea revolves around the possibility that the first stars were not uniform in their composition or behavior. Some may have been short-lived, exploding as supernova within a few million years, while others could have endured for much longer, shaping their surroundings in profound ways. These supernova, in turn, would have seeded the universe with heavier elements, paving the way for the formation of planets, and eventually, life. This cycle of creation and destruction is a recurring theme in the story of the cosmos, highlighting the interconnectedness of all things. As we explore these theories, it's important to remember that our understanding of the first stars is still evolving. Each new discovery, whether from the James Webb Space Telescope or other observatories, brings us closer to unraveling the mysteries of the cosmic dawn. These ancient stars, though long gone, continue to illuminate our path, guiding us as we seek to understand the origins of the universe and our place within it. And as we delve deeper into these theories, we're reminded that the story of the first stars is not just a tale of the past. It's a journey that connects us to the very fabric of existence. Now, as we turn our attention to the lasting legacy of these ancient stars, we begin to see just how profoundly they shaped the universe we know today. The first stars were not just brilliant beacons in the darkness. They were cosmic architects, laying the foundation for everything that followed. Their light, their energy, and even their deaths played a pivotal role in transforming the universe from a simple, featureless expanse into the complex and vibrant cosmos we inhabit. One of the most significant impacts of the first stars was their role in ending the cosmic dark ages. Before these stars ignited, the universe was shrouded in a thick fog of neutral hydrogen gas, blocking light from traveling freely. But as the first stars began to shine, their intense ultraviolet radiation ionized this gas, stripping electrons from hydrogen atoms and clearing the cosmic fog. This process, known as reionization, allowed light to travel across vast distances, making the universe transparent for the first time. It was a monumental shift, one that set the stage for the formation of galaxies and the intricate web of cosmic structures we see today. But the influence of the first stars didn't stop there. When these massive stars reached the end of their lives, they exploded in spectacular supernova, scattering their remains across the cosmos. These explosions were more than just dazzling displays. They were cosmic forges, creating and dispersing heavier elements like carbon, oxygen, and iron. These elements, forged in the hearts of stars and scattered by their deaths, became the building blocks for everything that followed: new stars, planets, and even the ingredients necessary for life itself. Without the first stars, the universe would have remained a barren place, devoid of the complexity and diversity we now take for granted. The first stars also played a crucial role in shaping the early galaxies. As they formed and died, their remnants gathered into dense clouds of gas and dust, which eventually collapsed under gravity to form new stars and star clusters. Over time, these clusters merged and grew, giving rise to the first galaxies. These galaxies, in turn, became the cradles of future star formation, hosting countless generations of stars and planetary systems. The first stars, in a sense, were the seeds from which the cosmic garden grew, their influence echoing through billions of years of cosmic history. Perhaps most remarkably, the first stars set the stage for the emergence of life. The heavy elements they created were essential for the formation of planets like Earth and the complex chemistry that makes life possible. Every atom in your body, every molecule in the air you breathe, can trace its origins back to the hearts of those ancient stars. They are the reason we exist, the reason we can look up at the night sky and wonder about the universe. In this way, the first stars are not just a part of our cosmic history, they are a part of us. As we reflect on the impact of the first stars, we're reminded of the profound interconnectedness of the universe. From the smallest atom to the largest galaxy, everything is linked by the actions of those ancient celestial pioneers. Their light may have faded long ago, but their legacy endures, shaping the cosmos and inspiring us to continue exploring the mysteries of the universe. And as we move forward in our journey, we'll see how the echoes of the first stars continue to guide us, even today. As we turn our gaze to the night sky, let us take a moment to appreciate the beauty of starlight, a timeless reminder of the first stars and their enduring legacy. The light that reaches us from distant stars is more than just a shimmering spectacle. It is a cosmic message, carrying the stories of ancient celestial fires that once illuminated the universe. Each twinkle we see is a fragment of history, a glimpse into a time when the first stars ignited and began to shape the cosmos. The light from those early stars traveled across unimaginable distances, piercing through the darkness of space and time. It is a testament to their power and brilliance that their light still reaches us billions of years later. When we look up at the stars, we are not just seeing points of light. We are witnessing the echoes of the cosmic dawn, a time when the universe was young and filled with the promise of creation. The beauty of starlight lies not only in its radiance, but also in its ability to connect us to the origins of everything we know. Starlight is more than just a visual phenomenon. It is a bridge between the past and the present. The photons that reach our eyes today began their journey long before Earth existed, carrying with them the energy and essence of the first stars. In this way, starlight is a living memory of the universe's earliest days, a reminder of the incredible journey that brought us here. It invites us to ponder our place in the cosmos and to marvel at the intricate web of connections that bind us to the stars. The significance of starlight extends beyond its beauty. It has inspired countless generations of thinkers, dreamers, and explorers, from ancient astronomers who map the heavens to modern scientists who study the universe's deepest mysteries. Starlight has been a source of wonder and discovery. It has guided sailors across oceans, marked the passage of time, and sparked the imagination of poets and artists. In every culture and every era, starlight has been a symbol of hope, guidance, and the infinite possibilities of the cosmos. And yet, starlight is also a reminder of the fragility and impermanence of the universe. The stars we see today will one day fade, just as the first stars did, their light dimming as they exhaust their fuel. But even in their passing, they leave behind a legacy of light, energy, and the elements that make life possible. The starlight we admire is a fleeting gift, a momentary connection to the vast and ever-changing universe. As we reflect on the beauty of starlight, we are reminded of the profound impact of the first stars. Their light not only illuminated the early universe, but also set in motion the processes that would lead to the formation of galaxies, planets, and life itself. In a very real sense, the starlight we see today is a continuation of their story, a story that began billions of years ago and continues to unfold with every passing moment. So the next time you find yourself beneath a starry sky, take a moment to appreciate the beauty of starlight. Let it remind you of the ancient stars that once burned brightly in the darkness and of the enduring legacy they left behind. In their light, we find not only beauty, but also a connection to the cosmos, a connection that transcends time and space, and that invites us to keep exploring, wondering, and dreaming. Now, let us step back and trace the grand arc of time, from the very beginning to where we stand today. The story of the universe is a tapestry woven over billions of years, and the first stars are among its most vital threads. It all began with the Big Bang, an unimaginable explosion of energy that set the stage for everything to come. In those first moments, the universe was a seething, chaotic sea of particles, too hot and dense for even light to escape. But as it expanded and cooled, the first seeds of structure began to form. For hundreds of millions of years, the universe remained shrouded in darkness, a time we now call the cosmic dark ages. During this era, the universe was filled with hydrogen and helium, the simplest elements, drifting aimlessly in the void. But gravity, the quiet architect of the cosmos, was already at work. Slowly, it pulled these clouds of gas together, compressing them until they ignited, giving birth to the first stars. These stars were unlike any we see today. Massive, luminous, and short-lived, they burned brightly and fiercely, lighting up the darkness for the first time. The light from these stars marked the end of the cosmic dark ages and the beginning of a new era. As they burned, they fused hydrogen and helium into heavier elements like carbon, oxygen, and nitrogen, the building blocks of life. When these stars eventually died in spectacular supernova, they scattered these elements across the cosmos, enriching the universe with the ingredients needed for future stars, planets, and even life itself. This was the first step in a cosmic chain reaction that would shape the universe as we know it. Over time, gravity continued to work its magic, pulling stars together into the first galaxies. These galaxies grew and evolved, merging and colliding, creating the vast structures we see today. Within these galaxies, new generations of stars were born, each one carrying the legacy of the first stars within them. And as these stars formed, so too did planets, some of which, like our own Earth, became cradles for life. Today, we stand at the end of this incredible timeline, looking back at a universe that has grown and changed over nearly 14 billion years. The first stars may have burned out long ago, but their light still echoes through the cosmos, a reminder of their role in shaping the universe. They were the pioneers, the first to illuminate the darkness and set the stage for everything that followed. Without them, the universe would be a very different place, a place without galaxies, without planets, and without us. As we reflect on this cosmic timeline, we are reminded of the profound interconnectedness of all things. The atoms in our bodies, the light in our skies, and the very fabric of the universe itself are all part of a story that began with the first stars. Their legacy is written in the stars above and in the world around us, a testament to the enduring power of creation. And so, as we gaze at the night sky, we are not just observers of the cosmos, we are part of its ongoing story, a story that continues to unfold with every passing moment. Now, let us shift our perspective and imagine the universe not as a vast, lifeless expanse, but as a living, breathing entity. Picture it as a cosmic being, slowly awakening from a deep slumber. In this grand metaphor, the first stars were its first breath of life, a spark of consciousness in an otherwise silent void. These stars were not just objects in space. They were the universe coming alive, stretching its limbs after an eternity of stillness. Their light was the first flicker of awareness, a signal that something extraordinary was beginning to unfold. As the first stars ignited, they set the stage for the universe's growth and transformation. Like a newborn taking its first steps, the universe began to explore its potential. The star's fusion of hydrogen and helium into heavier elements was akin to the universe learning to create, to build, to evolve. Each star was a heartbeat, pulsing with energy and purpose, driving the cosmos forward into new realms of complexity. And when these stars died in brilliant supernova, they were not endings, but moments of rebirth, scattering the seeds of future creation across the void. This living universe continued to grow, its galaxies forming like intricate networks of thought, each one a new idea, a new possibility. The first stars were the foundation, the starting point of a cosmic journey that would lead to galaxies, planets, and eventually life itself. In this way, the universe is not just a collection of objects, but a dynamic, evolving entity, constantly reinventing itself. The first stars were its first act of creation, and every star that followed has carried on that legacy, weaving the story of the cosmos into an ever-expanding tapestry. As we look out at the night sky, we are witnessing the universe in motion, a living entity that continues to grow and change. The light from distant stars and galaxies is not just a glimpse into the past. It is a reminder that the universe is alive, still breathing, still creating. And just as the first stars were the universe's first breath, we, too, are part of its ongoing story, a testament to its endless capacity for wonder and transformation. Now, let us pause for a moment and consider the profound silence that once enveloped the universe. Before the first stars ignited, space was a vast, soundless expanse, a cosmic void where no light, no sound, no movement broke the stillness. It was a silence so deep, so absolute, that it is almost impossible for us to fully comprehend. Yet, within this silence, something extraordinary was brewing. The first stars were not just a burst of light. They were a symphony of energy, a cosmic explosion that shattered the quiet and announced the universe's awakening. Imagine the contrast, the infinite hush of space, stretching endlessly in every direction, and then, suddenly, the birth of a star, a brilliant, roaring flame that tore through the darkness. These stars were not gentle or subtle. They were titans, blazing with unimaginable power. Their light pierced the void, their heat radiated across the cosmos, and their energy echoed through the fabric of space itself. Yet, even as they roared to life, the silence of space remained, a constant backdrop to their brilliance. It was as if the universe held its breath, watching in awe as its first creations came to life. This interplay between silence and energy is one of the most striking aspects of the cosmic dawn. The stars' explosive beginnings were not just a physical event. They were a moment of profound transformation, a turning point in the story of the universe. And yet, even as they burned brightly, the vastness of space absorbed their energy, their light, their sound, into its endless quiet. It is a reminder that, no matter how powerful or radiant something may be, the universe is always larger, always more mysterious. As we reflect on this contrast, we can find a sense of peace in the silence of space. It is a reminder that, even in the midst of chaos and creation, there is stillness. The first stars may have shattered the quiet, but they also illuminated the beauty of the void, revealing the universe's capacity for both stillness and energy. And as we gaze up at the night sky, we can feel that same balance, a quiet awe that connects us to the cosmos and its endless story. Now, let us journey back in time, not to the birth of the first stars themselves, but to the moment when humanity first gazed upon them and tried to make sense of their brilliance. Across cultures and civilizations, the first stars became more than just celestial objects. They were woven into the fabric of myth, legend, and belief. Ancient peoples, with no telescopes or scientific understanding, looked up at the night sky and saw stories written in the stars. These early interpretations reveal not only their awe, but also their desire to connect the heavens to their lives on earth. In many ancient cultures, the stars were seen as divine beings or the homes of gods. For the Greeks, the stars were often heroes and creatures immortalized in the sky, like Orion the hunter or the Pleiades, seven sisters transformed into stars. These myths were more than just tales. They were a way to explain the mysteries of the universe and humanity's place within it. The first stars in this context were not just sources of light. They were symbols of guidance, protection, and the eternal. Similarly, in Mesopotamian mythology, the stars were believed to be the work of the gods, who used them to mark the passage of time and to communicate their will. The Babylonians, skilled astronomers, mapped the stars and connected them to their gods, creating a celestial tapestry that guided both their agriculture and their spiritual lives. The first stars in their eyes were not random points of light, but deliberate creations, imbued with meaning and purpose. In the myths of the indigenous peoples of the Americas, the stars often played a central role in creation stories. For the Navajo, the first stars were placed in the sky by the holy people, who used them to bring order to the chaos of the early universe. These stars were seen as living beings, watching over the earth and its inhabitants. For the Maya, the stars were tied to the cycles of life and death, their movements believed to influence the fate of individuals and kingdoms alike. Even in cultures where the stars were not directly tied to gods or creation, they held deep significance. In Chinese mythology, the stars were part of a cosmic balance, representing the harmony between heaven and earth. The first stars were seen as the beginning of this balance, their light a reminder of the interconnectedness of all things. In these stories, the stars were not just distant lights, but active participants in the world, shaping its destiny and reflecting its rhythms. What unites these ancient interpretations is a sense of wonder and reverence. The first stars, though born from the cold mechanics of gravity and gas, became something far greater in the human imagination. They were symbols of hope, of order, of the divine. They were the first stories humanity told about the universe, and in telling them, we began to understand not just the stars but ourselves. As we reflect on these myths, we can see how the first stars continue to inspire us. They remind us that the universe is not just a collection of physical phenomena, but a source of endless stories, each one a reflection of our curiosity and our need to find meaning in the cosmos. And as we look up at the night sky today, we carry forward that ancient tradition, finding in the stars not just light, but a connection to the countless generations who came before us, gazing upward in wonder. As we turn our gaze from the myths of the past to the questions of the present, we find that the mystery of the first stars continues to ignite a spark within us, a spark of curiosity. This curiosity is not just a fleeting wonder, but a driving force that has propelled humanity to explore the cosmos, to seek answers to questions that have lingered since the dawn of time. The first stars, those ancient beacons of light, are more than just a chapter in the universe's history. They are a call to discovery, a reminder that the cosmos is vast, mysterious, and full of stories waiting to be uncovered. From the earliest astronomers who charted the night sky to the modern scientists, peering through powerful telescopes, the first stars have always been a source of fascination. They represent the unknown, the unexplored, and the infinite possibilities that lie beyond our reach. This curiosity is not limited to scientists alone. It lives in all of us. Whether we are stargazers lying on a grassy field or dreamers imagining distant worlds, the first stars remind us that the universe is a place of endless wonder, inviting us to ask questions and seek answers. What is it about these ancient stars that captivates us so deeply? Perhaps it is their simplicity, their purity. Unlike the stars we see today, which are rich with elements forged in the hearts of countless generations, the first stars were made of only hydrogen and helium. They were the pioneers of the cosmos, the first to light up the darkness. In their light, we see the origins of everything, the building blocks of galaxies, planets, and even life itself. They are a window into the past, a way for us to glimpse the universe as it was in its infancy. But the first stars are also a challenge. They are a reminder of how much we still do not know. Despite all our advancements in science and technology, we have yet to directly observe these ancient luminaries. They remain elusive, their light faint and distant, obscured by the passage of time. Yet, this very elusiveness drives us forward. It pushes us to build better telescopes, to develop new ways of seeing, and to imagine new possibilities. The first stars are not just a mystery to be solved, they are a journey to be undertaken. This journey is not just about science, it is about our place in the universe. The first stars remind us that we are part of something much larger than ourselves. They connect us to the cosmos, to the countless generations who came before us, and the countless more who will come after. In their light, we find not just answers, but also questions that inspire us to keep exploring, to keep dreaming, and to keep reaching for the stars. As we continue to unravel the mysteries of the first stars, we are reminded that curiosity is one of humanity's greatest gifts. It is what drives us to look beyond the horizon, to seek out the unknown, and to find meaning in the vastness of the cosmos. The first stars, in their quiet brilliance, are a testament to this spirit of exploration. They are a reminder that the universe is not just a place to be studied, but a story to be lived, a story that we are all a part of, written in the light of the stars. As we shift our gaze from the scientific to the artistic, we find that the first stars have not only illuminated the cosmos, but also inspired the human imagination. Across cultures and centuries, these ancient luminaries have been woven into the fabric of art and literature, serving as symbols of hope, mystery, and the infinite. They are not just celestial bodies but muses, sparking creativity and wonder in those who look to the skies. In literature, the first stars often appear as metaphors for beginnings and possibilities. Poets and storytellers have long used their light to evoke a sense of awe and curiosity. For instance, in ancient myths, the first stars are sometimes portrayed as the eyes of gods, watching over the world and guiding humanity through the darkness. These stories remind us that the stars are not just distant objects, but part of our shared human experience, connecting us to something greater than ourselves. Art, too, has been deeply influenced by the first stars. From the intricate star maps of ancient civilizations to the breathtaking cosmic paintings of modern artists, the first stars have been a recurring theme. They are often depicted as delicate points of light breaking through a vast, dark canvas, symbolizing the triumph of light over darkness. These artistic interpretations capture not just the beauty of the stars, but also their profound significance. They are a reminder of the universe's origins and our place within it. Even in contemporary works, the first stars continue to inspire. Science fiction writers imagine distant worlds orbiting these ancient suns, while visual artists create stunning representations of the cosmic dawn, blending science and creativity. These depictions invite us to see the first stars not just as scientific phenomena, but as sources of inspiration, encouraging us to dream and explore. Through art and literature, the first stars become more than just objects in the sky. They become stories, symbols, and sources of wonder. They remind us that the universe is not just a place of facts and figures, but also of beauty and imagination. As we continue to explore the mysteries of the cosmic dawn, let us also celebrate the ways in which these ancient stars have ignited the human spirit, inspiring us to create, to dream, and to reach for the stars. As we turn our gaze inward, the story of the first stars becomes more than a tale of cosmic history. It becomes a mirror reflecting humanity's deepest questions. For as long as we have looked up at the night sky, we have sought meaning in the stars. They are not just distant lights, but symbols of our curiosity, our longing to understand where we come from and where we are going. The first stars, those ancient beacons of light, remind us that the universe is vast and mysterious, yet somehow we are a part of it. In many ways, the search for the first stars mirrors our own search for meaning. Just as astronomers piece together clues from the faintest glimmers of light to uncover the story of the cosmic dawn, we too gather fragments of knowledge and experience to make sense of our existence. The first stars teach us that even in the darkest times, light can emerge, and from the simplest beginnings, complexity and beauty can arise. They remind us that the universe is not just a place of chaos, but also of order, of patterns that connect us to something greater. The first stars also challenge us to think beyond our immediate surroundings. They existed long before Earth, long before life, and yet their light still reaches us, a reminder of the vast timeline of the cosmos. This perspective can be humbling, but it can also be empowering. It invites us to see ourselves as part of a grand, unfolding story, one that began with the first stars and continues with us. In their light, we find not just answers but also questions, not just certainty but also wonder. For some, the first stars are a reminder of the fragility and preciousness of life. They existed in a universe that was once dark and empty, and yet they shone, transforming the cosmos. In the same way, our lives, though brief in the grand scheme of the universe, have the potential to create light and meaning. The first stars inspire us to look beyond our individual struggles and see the bigger picture, to find purpose in the connections we make and the legacy we leave behind. Ultimately, the story of the first stars is a story of hope. They remind us that even in the vastness of space, there is a place for us, a role for us to play. They encourage us to keep searching, to keep asking questions, and to keep dreaming. As we ponder the mysteries of the cosmic dawn, we are not just exploring the universe, we are exploring ourselves, our place in the cosmos, and the meaning we choose to create. And in that search, we find not just answers, but also the beauty of the journey itself. As we continue our journey through the mysteries of the cosmic dawn, let us pause for a moment to reflect on the first stars, not just as cosmic phenomena, but as symbols of something deeply human: hope. These ancient stars, born in a universe that was once dark and silent, remind us that even in the bleakest of times, light can emerge. They are a testament to the power of beginnings, no matter how small or fragile they may seem. Just as the first stars ignited in a vast, empty cosmos, we too have the ability to create light in our own lives, even when the world around us feels overwhelming. The first stars teach us that beginnings are not always easy. They formed in a universe that was cold and chaotic, yet they found a way to shine. In the same way, our own journeys often start in uncertainty, in moments of doubt or struggle. But like those first stars, we have the potential to transform darkness into light, to turn challenges into opportunities for growth. The story of the cosmic dawn is not just about the birth of stars. It is about the resilience and creativity that define all beginnings, whether in the cosmos or in our own lives. Consider how the first stars, though they burned brightly for only a short time, left a lasting impact on the universe. Their light traveled across billions of years, reaching us here and now. In a similar way, the choices we make, the actions we take, and the hope we nurture can ripple far beyond our immediate surroundings. The first stars remind us that even the smallest spark of hope can have a profound effect, not just on our own lives, but on the lives of others. They encourage us to believe in the power of our own light, no matter how faint it may seem. The first stars also symbolize the idea of renewal. After their fiery lives ended, they scattered the elements needed to create new stars, planets, and even life itself. In this way, they became the seeds of a new cosmic era. This cycle of creation and renewal mirrors our own experiences of starting over, of finding hope after loss, and of rebuilding after hardship. The first stars show us that endings are not final. They are often the prelude to new beginnings, to new possibilities waiting to unfold. In the end, the first stars are more than just a chapter in the story of the universe. They are a metaphor for the hope that resides within all of us. They remind us that no matter how dark the night, dawn will come. They inspire us to keep moving forward, to keep believing in the possibility of light, even when it feels distant. As we gaze at the stars, let us remember that we, too, are part of this grand cosmic story, a story of hope, of resilience, and of the enduring power of new beginnings. And with that thought, we prepare to explore the next chapter of this celestial journey, where the echoes of the first stars continue to shape the universe we know today. As we turn our gaze to the legacy of the first stars, we begin to see how their brief but brilliant existence shaped the very fabric of the universe. These ancient stars, though they burned out long ago, left behind a cosmic blueprint that continues to influence everything we see today. Their light, their energy, and even their remnants became the foundation for all that followed: galaxies, planets, and ultimately, life itself. The first stars were not just the beginning of light in the universe, they were the architects of its future. One of the most profound legacies of the first stars lies in the elements they created. When these massive stars ended their lives in spectacular supernova, they scattered heavy elements like carbon, oxygen, and iron across the cosmos. These elements, forged in the hearts of the first stars, became the building blocks for everything that came after. Without them, the universe would have remained a sea of hydrogen and helium, unable to form the complex structures we see today. The first stars, in their fiery deaths, gave the universe the tools it needed to evolve, but their impact goes beyond the physical. The first stars also transformed the universe on a fundamental level. Their light began to ionize the surrounding gas, breaking apart the neutral hydrogen that had dominated the cosmos since the Big Bang. This process, known as reionization, marked the end of the cosmic dark ages and set the stage for the universe to become transparent to light. It was a turning point, a moment when the universe began to take on the form we recognize today. The first stars, in this sense, were not just creators of light, they were the pioneers of a new cosmic era. Their legacy also extends to our understanding of the universe itself. By studying the faint echoes of their light, astronomers have been able to piece together the story of the cosmic dawn. These ancient stars serve as a window into the early universe, offering clues about how the first structures formed and how the cosmos evolved over billions of years. They remind us that the universe has a history, one that is written in the stars and waiting to be discovered. Perhaps most importantly, the first stars remind us of the interconnectedness of all things. Their light, their elements, and their energy are woven into the fabric of the universe, and by extension, into us. The atoms in our bodies, the air we breathe, and the ground beneath our feet all trace their origins back to those ancient stars. In this way, the first stars are not just a part of cosmic history, they are a part of us. As we reflect on their legacy, we are reminded of the enduring power of beginnings. The first stars, born in a universe that was once dark and empty, set in motion a chain of events that led to the richness and diversity we see today. They teach us that even the smallest spark can ignite a transformation, that even the briefest light can leave a lasting impact. And as we continue to explore the mysteries of the cosmos, we carry their legacy with us, a reminder of the beauty, the complexity, and the infinite possibilities of the universe. As we come to the end of our journey through the cosmic dawn, let's take a moment to reflect on the profound beauty and mystery of this ancient era. The first stars, those luminous pioneers of the universe, remind us of the incredible power of beginnings. They emerged from the darkness, igniting a cosmic transformation that shaped everything we know today. Their light, their energy, and their legacy continue to echo across the vast expanse of space, connecting us to the very origins of the universe. The story of the cosmic dawn is not just a tale of stars and galaxies, it's a story of wonder, of possibility, and of the infinite potential that lies within the cosmos. It invites us to look up at the night sky with fresh eyes, to marvel at the intricate dance of light and matter that has been unfolding for billions of years. And as we drift into sleep, let this sense of wonder carry us into our dreams, where the mysteries of the universe can unfold in our imaginations. If this journey through the cosmic dawn has sparked your curiosity, I'd love to hear your thoughts. What did you find most fascinating about the first stars? How does their story inspire you? Share your reflections in the comments below. I'm always excited to hear from fellow cosmic explorers. And if you'd like to join me on more journeys through the wonders of the universe, don't forget to subscribe and hit the notification bell so you never miss a new cosmic sleep story. Thank you for letting me guide you through this incredible chapter of cosmic history. As you close your eyes tonight, remember that the stars above are not just distant lights. They are part of a story that began long ago, a story that continues to unfold with every passing moment. Sleep well, dream deeply, and may the mysteries of the universe fill your nights with wonder. Until next time, sweet dreams.